Okay, simplify the following expressions. When you're simplifying, you first take the numbers and you reduce the fractions. So 15 divided by 45 reduces to 1 over 3. And then you look at the e's and you treat them just like a variable. If you have e to the 6 on top, it's bigger on top, so it's going to stay there. And then the exponent is going to be 6 minus 4 is 2. So I'm going to rewrite that as e squared over 3. The next one. The first one is squared. So you're going to do 3 squared is 9. And then e to the 3x to the power of 2 is e to the 6x. And you're multiplying that by 2e to the negative 4x plus 7. So to simplify it, you need one number. We have 9 and 2. Multiply those and you get 18. One variable, which is e, that's 6x minus 4x is 2x plus 7. That's kind of easy. Number 12, it's the cubed root. So you can rewrite 125 as 5 times 5 times 5. And with that being a 3, you circle it, so the cubed root of 125 is 5. And then when you have a variable, you're going to take the exponent, and that's 12 divided by 3 is 4x. And that's your answer. Okay, let's go to convert these exponential equations into logarithms. You have to remember that the whole purpose of logarithms is to solve when the variable is an exponent. So if I write log down, what it's going to equal is the exponent, which is an x. The base of the exponent is the base of the log, and that number 9 fills in the empty spot. On number 14, we're going to make it into a logarithm again. And so you're going to write the word log. And you have to remember that the whole purpose is to solve for the exponent. So the exponent is going to be what it equals. The base of the exponent is the base of the log. And that other number fills in the empty spot. Same thing here, except that in this case, the base is an e, so we'd be using natural log instead of regular log. It's going to equal 2x, and you can put the e there if you want. You do not have to, because if you're using natural log, it is going to be e. Okay, so those are converted. Now the next directions say to evaluate the following logarithms. So now they're wanting a value for it. So we know this equals some number. We don't know what that is, but I'm going to switch it back to the exponent. So what it equals is the exponent, and the base of the log is the base of the exponent, and it equals 64. So I can do 4 to the x equals 4 to the third power. Once you have the same bases, you can ignore them, and x equals 3. Okay, so here you have log base 2 of 0.125 equals some number. So I know the base of the log is the base of the exponent, and it's going to equal 0.125, I think it's 1/8. I'm going to put 0.125 in the calculator and change it to a fraction, and it is 1/8. Okay, we have to have common bases to solve this. And so 2 is going to be your base. This is 2 to the x and it equals 1 over 2 to the third power. Except that has to go into the numerator, so I'm going to rewrite it. And you have 2 to the x equals 2 to the negative 3. Remember, if you move it from the numerator to the denominator or the denominator to the numerator, you have to change the sign on the exponent. So now that we've done that, the 2's are the same, therefore the exponents have to be the same. Okay. Last one of these. This is going to equal the exponent, so we know the base of the log is the base of the exponent, and it equals 1. The bases have to be the same, and how are you ever going to get 1? Well, if you remember, anything to the 0 power is 1. So if I had 18 to the 0 power, it equals 1. Bases are the same. X equals 0.